everybody, I hope you guys are having a wonderful day today. So this lesson, which is section 3.7, is all about how we can combine functions together to create new functions. So let's say, for example, that we had three different functions. So we have f of x, where you take an input of x and you multiply it by 3 and then add 3. And then you have g of x, which is 6x times or plus 6. So you take whatever your input is, multiply by 6 and add 6. And then you have another function called h of x that takes your input and squares it, multiplies by 9, and then adds that result to 18 times the input and then adds 9. So if we have these three different functions, we can create new functions by adding, subtracting, multiplying, or dividing these functions together. So for example, if you're asked to find the function f plus g of -5, what this basically means is that you're going to input -5 into g, and you're also going to input it into f, and then you'll add the results of them together. So the way that you would calculate this is you would say, okay, well, if I input -5 into f, I get 3 times -5 plus 3, and I could simplify out what that is going to be. And then I'm going to add this to the result of g if I input -5. So if I do 6 times -5 and add 6 to that, if I take that, that would be the result of inputting a -5 into g. And the function f plus g is basically going to be those two results added together. So I could simplify this and I could say, well, 3 times -5 is -15. If I add 3, that gives me -12. And so I'm going to have -12 plus 6 times -5 is -30. If I add 6, that's going to give me -24. And so I get -12 plus -24, which equals a total of -36. And so -36 would be the output when you input a -5 into the function f plus g. So why don't you try these other three and then restart the video to see how I would solve these ones. Okay, so for this next one, where we're finding h minus g of 2, I'm going to take 2 and plug it into h. So that gives me 9 times 2 squared plus 18 times 2 plus 9. And all of that is going to be subtracted by g of 2, which is 6 times 2 plus 6. And so I'd say, okay, well, 2 squared is 4. 4 times 9 is 36. 18 times 2 is also 36. And then I have plus 9. And then I'm going to subtract 12 plus 6, which is 18. So it's really important when you subtract a function that you remember to subtract the entire thing, because it would give you a different answer if you subtracted 12 and then added 6. But you need to subtract 12 plus 6, which means you're subtracting 18. So you can do that by distributing the negative to each term, or you can just simplify this and then figure out what it would be when you subtract that. So to finish this out, we'll do 36 plus 36 is going to be 72. Plus 9 would give you, I think, 81. And then if you subtract 18 from 81, you're going to get 63, I think. I might have calculated that wrong, so if I didn't do that arithmetic correctly, you can fix that mistake yourself. But I think it would be 63 because you get 72, 81, and 81 minus 18, I think, would equal 63. So that's how you do that one. And then if you do f times g of 0, so this notation means you're multiplying f times g, then essentially you're going to plug 0 into f. So you get 3 times 0 plus 3, and then that whole thing is going to be multiplied by 6 times 0 plus 6. And when you simplify that, 3 times 0 plus 3 is just 3. 6 times 0 plus 6 is just 6. And so the output of f times g when you input a 0 would be 18. And then if we do this last one, and we do h of negative 3 divided by f of negative 3, we would get 9 times negative 3 squared plus 18 times negative 3 plus 9, all divided by f of negative 3, which is 3 times negative 3 plus 3. And when I simplify that, negative 3 squared is 9, and 9 times 9 is 81. Then negative 3 times 18 would be, I think, 54, or negative 54, pretty sure. And then if you add 9 to that, that would give you the output of h. And then if you divide by negative 9 plus 3, we can simplify this even further because 81 plus 9 is 90. If you do 90 minus 54, you're going to get 36. Divided by negative 9 plus 3 is negative 6, and this would give you negative 6. So if I made any mistakes in the simplification of this, I'm sorry, I was doing it in my head. I didn't have my calculator nearby. But based on my calculations, I think the output would be negative 6. So that's how you can add and subtract and multiply and divide functions. And sometimes you'll also be asked to find the addition or subtraction or multiplication of functions where you're not given a specific input. So in this case, if we were asked to find f plus g of x, then we would just say, okay, well, I'm going to input x into the function f, which gives 5x squared plus 7x minus 6. And then I'm going to take that and add the function g. So I'm going to add 5x minus 3, because if I take x and put it into g, this is what I get out. And then you can simplify this by combining like terms. So in this case, the parentheses right here are not needed because there isn't anything being multiplied outside. So we can essentially just get rid of those parentheses. And then if I'm adding this stuff, I don't need to distribute the addition because it won't change anything. So I can essentially get rid of those parentheses as well. And then I can combine my like terms, which would give me 5x squared plus 12x, because if I do 7x plus 5x, that gives me 12x. And then I get a negative 9 when I combine negative 6 and negative 3. And so this would be the simplified version of this function. And then you could also do this with subtraction. So if I had 5x squared plus 7x minus 6, when I input an x into f, then I could subtract the function that I get out, or the output that I get out when I input an x into g. So if I subtract 5x minus 3, in this case, this set of parentheses does matter because I'm subtracting the whole thing. And so I could rewrite this as 5x squared plus 7x minus 6 minus 5x plus 15. Because I'm subtracting the 5x, but I'm also subtracting the negative 3. And if you subtract a negative, oh, sorry, it shouldn't be 15. It should be a 3. I made a mistake there. Yeah, so it should be plus 3 because I'm subtracting the 5x and I'm subtracting the negative 3. Then you could simplify this by combining like terms, which would give you 5x squared plus 2x minus 3. And that would be your output when you input an x. Now, if you are multiplying functions together, then you would, again, basically go through the same process where you say, well, I take x, put it into f, which gives me 5x squared plus 7x minus 3, or minus 6. Then I would multiply that by 5x minus 3. And to simplify this one, you would need to FOIL or multiply these out. So you do like 5x squared times 5x, then you do 5x squared times negative 3. Then you do 7x times 5x and 7x times negative 3 and negative 6 times 5x and negative 6 times negative 3. And you would simplify all of that out, combine any like terms, and then that would be your result for f times g of x. Same thing if you were doing f divided by g of x. In that case, you would get 5x squared plus 7x minus 6 divided by 5x minus 3. And because this is not a monomial, then you would need to do long division to simplify out what f divided by g of x is. But the basic idea is that you take x and you input it into f, you take x, input it into g, and then you divide the results. And there's one other type of problem that you'll see on your homework, and it's called a composition of functions. So if you're doing f compose g of x, what that means is you take x and you put it into g, and then you take the result and put that into f. And so what this would look like is you would say, okay, well, if I take x and put it into g, then I get 5x minus 3. And then if I take that result and put it as the input of f, I would take that and multiply by 2 and minus 1. Because f says to take your input and multiply it by 2 and subtract 1. And so if you take the result of putting x into g and put that into f, you would end up with something like this. And then you can simplify it by saying, well, 2 times 5x minus 3 is 10x, and 2 times negative 3 is negative 6, minus 1, and then you'd end up with 10x minus 5, or sorry, minus 7 for that result. So a composition of functions is basically where you take x, put it into the closest function, then you take that result and put it into the next function. And the order does matter because if you were to do g compose f of x, so if I take x and put that into f, that would give me 2x minus 1. Then if I take that result and put that into g, so g says to take the input and multiply by 5, then subtract 3, then that would give me 10x minus 5 minus 3. And you can see that this gives you a different result as your like simplified version of the function than if you did f compose g. So you do need to make sure you pay attention to the order of which order the functions were listed in. But basically when you compose functions, you're kind of like layering the functions on top of each other. So why don't you guys go ahead and try these 4 problems and then pause the video and then restart it to see how I would solve these. Okay, so on this first one, I'm going to put x into g, which gives me an output of 3x minus 2. And then I'm going to take that and input that in for f. And so if I input this in for f, f says to take the input and square it. So I'm going to square that binomial. And in order to simplify this, I would write this out as 3x minus 2 times 3x minus 2. And then I would distribute 3x times 3x equals 9x squared. 3x times negative 2 gives me negative 6x. Negative 2 times negative 2 times 3x gives me negative 6x as well. And negative 2 times negative 2 gives me positive 4. And when I combine like terms, my fully simplified composed function would be 9x squared minus 12x plus 4. And so that would be my composed function, f compose g. And if I do g compose f of x, that means that I would put x into f, which gives me x squared, and then I would take that and put that into g. So g says you do 3 times the input, so I'll do 3 times x squared, and then you minus 2. And that's actually already fully simplified, so you wouldn't have to do it any further than that. And then if you're asked to do it with numbers, you can do it by taking 4 and putting it in for g. So you say, okay, well, if I put 4 into g, I'll have 3 times 4 minus 2. Figure out what that is, which I think it would be 12 minus 2 is 10. And then take that result and put that in for f. So I take this and I square it, which would end up giving me 100. So you can do it that way. Or another way you can also do it is you can take a 4 and plug it into all of the x's in your simplified f compose g of x. And if you did that, you would get the same result. In this case, I think it'd probably be easier to do it this way, but you could plug in a 4 for all of your x's in the original or the first part, because in this one, you're inputting an x into G and then into F, and in this one, you're basically just replacing the x with a 4. And then you could do the same thing for the last one. So if I do that, if I take -1 and input it into F, -1 squared is +1. And then if I apply G to that by multiplying 3 and then subtracting 2, well, 3 times 1 minus 2 is just going to equal 1. And you could get that same answer if you took -1 and plugged it into this function. Because -1 squared is +1, 1 times 3 is 3, minus 2 would still give you this answer of 1. So on those ones, you can do it either way. And I think on your homework, they give you a bunch of problems where they're grouped like this, where you have to find the composition of the functions with the x's. And so on the ones where you find the composition of functions with numbers as your input, you can just use the problems that you've calculated earlier if you'd like. So that's how you find, or that's how you calculate those problems. If you have any questions, you can ask me on Friday, or you can also come to my office hour. So I hope you guys have a good day, and I'll see you guys on Friday.